Today, you will learn how to calculate various statistical relationships and understand their significance in data analysis. For example, calculate the covariance between two data sets and interpret the result. Calculate the linear correlation coefficient between two sets of variables and interpret the result. Perform linear regression analysis to estimate the relationship between two sets of variables and make predictions. Covariance. Covariance is a statistical measure used to quantify the degree to which two variables change together. It is a measure of the relationship between two random variables and assesses the covariability of two variables around their respective means. Let's discuss the formula for calculating covariance. We start with population covariance. Here, n is the number of pairs of observations or the population size. Moving on, we have sample covariance. Now let's delve into the interpretation of these calculations. Interpreting the results of covariance is crucial. If the covariance between x and y is greater than 0, it indicates a positive linear relationship. It implies that as the value of x increases, the value of y also tends to increase, and vice versa. If the covariance between x and y is less than 0, it indicates a negative linear relationship. It implies that as the value of x increases, the value of y tends to decrease, and vice versa. Lastly, if the covariance between x and y is equal to 0, it indicates no linear relationship. Linear correlation. Linear correlation is a measure of the amount of association existing between two variables. For linear correlation, if points are plotted on a graph and all the points lie on a straight line, then this indicates a perfect linear correlation. When a straight line having a positive gradient can reasonably be drawn through points on a graph, positive or direct linear correlation exists. See the figure below. Conversely, when a straight line having a negative gradient can reasonably be drawn through points on a graph, negative or inverse linear correlation exists. See the figure below. And when there is no apparent relationship between coordinate values plotted on a graph, then no correlation exists between the points. See the figure below. Correlation coefficient formula. The correlation coefficient can be found using the formula below, wherein is the number of pairs of observations. Interpretation of the results of correlation coefficient is crucial. See the table below. Linear regression. Linear regression is a statistical method used for modeling the relationship between a dependent variable and one or more independent variables. Simple linear regression involves just two variables, one independent variable, x, and one dependent variable, y. Formula. The relationship between x, the independent variable, and y, the dependent variable, can be modeled using the equation. where a1 is the slope of the line and a 0 is the y-intercept, which are calculated using the formulas below. Thanks for watching.